Hello guys, myself Punicham and I welcome all to my YouTube channel Punicham, and I am a student of Sri Venkateswara College of Engineering. Myself Punicham, and we'll discuss about mathematics for CSE 3. USN is 1V22 CS 120 and we belong to a class Bhaskara 3rd semester, Department of Computer Science and Engineering. First we'll come to the topics that we are discussing today. First of all, probability distribution. There is the first module of Engineering Maths 3, and in that we will discuss the first three topics. There are random variables, binary distribution, Poisson distribution. First we will discuss what is probability. As you know that the probability the event E is given by P of E is equals to number of favorable outcomes by number of possible outcomes, that is equals to m by n. The probability at most is equals to 1 because the number of favorable cases and the possible cases can at most consider within each other. The probability of not appearing event is given by P of E bar, that is equals to P of E bar is equals to 1 minus P of E, as P the number of favorable and unfavorable condition is equals to 1. We'll come to the addition theory of probability. What is this addition theory of probability? The probability of the happening of one or more addition theorem. We'll come to the addition theory of probability. The probability of happening of one or the other event is equal to the sum of the probabilities of the two events. That is P of A or B is equals to P of A plus P of B. Next we will see the product theorem of probability. The probability of the happening of a component event is equal to the probability of the independent event, that is equals to P of A and B is equals to P of A into P of B. Now we'll come to the main topic of this session, that is random variables. What is random variables? If a real number are associated with each other with each outcome, then it is called as random variables. The random variables are denoted by x, y, z, so on, and it may be noted that different random variables may be associated with the same sample space. There are types of random variables. There are two types of random variables, discrete random variables and continuous random variables. We will discuss about the discrete random variables. What is discrete random variables? If a random variable takes the finite number of values, then it is known as discrete random variables. Continuous random variables. If the random variables take infinite number of values, then it is called as continuous random variables. We'll come to the discrete probability distribution. What is this discrete probability distribution? How it is maintained and how it is done, we will see. If for each values of xi of a discrete random variable x is associated with a real number p of xi such that p of xi is greater than 0 and summation of p of xi is equal to 1, then the function p of x is called as probability function. We'll come to the formulas for finding the mean, variance and standard deviation. Mean is equals to summation I is equals to 1 to infinity xi into p of xi. Variance is equals to v. It is denoted by capital V. Capital V is equals to summation I is equals to 0 to infinity xi minus mu whole square into p of xi. Standard deviation. Standard deviation is equals to square root of variance. Standard deviation is denoted by sigma. We'll come to the binomial distribution. What is binomial distribution? If a p is the probability of success and q is the probability of failure, the probability of x success out of n trials is given by P of x is equals to ncx p power x cube power n minus x, where where x is the number of outcoming and n is the number of incoming. P of x is equals to c combination of ncx p power x q power n minus x. We form the following probability distribution of x p of x, where x is equal to 0 1 up to n. You can see in this table that there is a distribution of from 0 to n. We'll come to the mean standard deviation of the binomial distribution. As I said, that mean is equals to mu, that is equals to np, and variance p is equals to npq, and standard deviation is equals to root over variance, that is equals to root npq. We'll come to the Poisson distribution. Poisson distribution. Let x be the discrete random variables for a real number of a parameter such that the probability mass function of a Poisson distribution can be defined as p of x is equals to x e power minus lambda lambda power x by x factorial, where x is equals to 0 to n and otherwise 0 otherwise. Note that p of x is equals to x is greater than equal to 0, where mean mu is equals to np, that is equals to lambda, where variance psi square is equals to lambda, that is equals to st is equals to root over lambda. I thank you for all of you. I think it was a good presentation. Thank you.